Hi, we're going to take a look at grading an FRQ, problem number 3 from 1999's AP Stats test. And it's all about eating an apple a day and cavities, okay? And they give you a little scenario right here. And the first question A says, why is this an observational study and not an experiment? Oh my gosh, this problem has popped up again, all right? Being able to identify and know the buzzwords here is important. They're already telling you it's observational study, so this should be an easy point. It's an observational study since treatments of apple eating or not were not imposed, all right? So saying that the treatments were not imposed, all right? And then I want you to make sure that you look around here and see, do you have context? I talked about apple eating or not, because those are the treatments that they're sort of implying that they're sort of using, but they're really not treatments because there was no random assignment. So the second check right here is going to be based on context, and so I got a 2 out of 2 on this particular problem. Now the AP also said in this particular problem that because random assignment wasn't used, that would be another way of being able to get credit for the right justification. I like imposing treatments and not imposing treatments. I also included that randomization wasn't used to make sure that I really had a complete response. Now for part B, it says explain the concept of confounding. Now we know that confounding is some variable is going to impact the response variable and somehow is connected to the explanatory variable that we're actually testing out. And so I wanted to make sure that I defined it a little bit, and I wanted to make sure that my solution has that statistical vocab definition kind of thing, that I know that it somehow impacts the response variable. I need that to be written down in there for that first check. I want to make sure that I'm sort of wowing them with my vocabulary, okay? Now the next check is going to be the one that I think is cooler to write about, and that means, remember, this is that circle kind of thing. Pick a variable that somehow is connected to the explanatory and the response, and then you need to elaborate about it in a sort of like a fun kind of way. You get to come up with the variable. So here we say that overall healthy diet reduces cavities, and not just the apples. Maybe people with healthy eating habits brush their teeth more and then have fewer cavities. To get the full credit for part B, there had to be some kind of example that actually connected up the two variables that you're working with, which is the apple eating to healthy eating, then all the way connected to the cavities that they get. All right, so this is also worth 2 points, talking about definition of confounding variable, and then secondly, an example. So 2 points for this particular problem. So in this case, for part C, it says, wow, they did a test and they found out that there was a statistically significant smaller than mean number of new cavities. Now that means that they did a test and the p-value was low, and so they rejected the whole and they found out, well, there's a difference. And then it says, can one conclude that it's attributable to apple eating? And the answer here obviously is going to be no. Okay, and I want to make sure that this is very, very, very clear in 2 different ways. It is clear because this is an experiment. All right, it's an experiment, and so that means that you cannot say anything about causation. So your justification needs to be experiments, okay, show causation. This is not an experiment, this is an observational study, so we cannot say that there is going to be a cause-effect relationship right here. Okay, now that bottom line is going to give you full credit for this particular problem, saying no, because it's not an experiment, there's no causation. Those are the 3 checks. You can get a 3 out of 3 that way. Now there's another way that the AP actually, like you could talk about it a little bit differently, and I elaborated a little bit right here, that one of the conditions for inference when you're doing a 2-sample t-test, because you're looking at number of cavities, and that's quantitative data. So you're going to have the apple a day eating ones with a number of cavities, the non-apple eating number of cavities. So you have 2 sets of cavity numbers, and you're checking to see if there is a difference. So it is a 2-sample t. Conditions wise, remember, randomization has to be true for both groups. And in this case, there was no randomization, so you're really not allowed to do the test because your conditions weren't satisfied. Ugh. All right, so in this particular problem, there are 7 points right here. My person, which was me, all right, got 7 out of 7 for this particular problem, and that concludes this particular grading experience.